number one. Chandler, what do you have for number one? Mechanical weathering is the process of A, breaking rocks. That is absolutely correct. Number two. Let's see here. Ty, chemical weathering is the process of? It's going to be A, breaking rocks. They're both weathering, so they're both breaking the rocks into smaller sediments. Number three, Madison, erosion is the process of? B, moving. Weathering is the breaking, erosion is the moving. Number four, which can move sediments more effectively? Natalie. A, fast water.
Very good.
It hits the particles harder with the higher speeds, and so it can pick them up easier. Number five, what happens to sediments because the water slows down? Logan, what do you got? Yep, deposition.
Let's go.
Since the water slows down, it's not hitting the sand particles as hard, and so the larger sand particles can settle down to the bottom. Okay, new notes. First of all, we have deltas. Are fan-shaped peninsulas made when water slows down as it enters the ocean. So let's say we have a river here, and it empties into the deep ocean. So here's ocean, and over here is the river. River here is flowing pretty well. It's hitting the sand particles hard, and so it lifts them up and carries them down. However, the ocean is very still relatively to a river. The currents are not moving as fast as a river would be, and so that means that the sand and gook settles down to the bottom at that location, and so it builds up a peninsula. And we can see a picture of it right here for the Mississippi River. These can be miles and miles and miles long. Next, alluvial fans are cone-shaped piles made when water slows down at the bottom of a mountain. Yep. So here we have a very steep hill going to a flat-bottomed valley. When the sediments hit the valley bottom, they can't be carried by the water so well, so they make a little pile. But that little pile grows over the years, and we end up with this giant pile here called an alluvial fan. Sand dunes are made when wind carries sand over a hump. On the downwind side, of the hump, the sand is shielded from the wind so it doesn't move. Sand is moved from the upwind side to the downwind side. The dune gradually moves across the desert. So over here we have sand that's being bounced along the ground, being blown by the wind a few feet, then it drops, but then it gets blown by the wind again. However, when it bounces over the top of the hill to the other side, now it doesn't get hit by the wind anymore, and so it doesn't move. Gradually, the sand gets moved from one side to the other side, and the whole sand dune appears to move across the desert. Next, islands can appear off the ocean shore and disappear in a short period of time. Now, these aren't really great islands. They're more like sandbars. But you can go out and you can walk around and you can build sand castles, have a picnic, whatever, but they might disappear because of erosion after just a few days. Here we have a picture of 2016. There is no island down here at all. 2017, there it is. And in 2017, later on July, it's even bigger. But then it disappeared. Erosion carried it all away. The course of a river will change as one side erodes more than the other. So here we have just a little bit of a wiggle to the river, but as every turn happens, the water, with its inertia, with its momentum, will slam against the outside of the curve more than the inside. And so that causes erosion to occur here, and the bank will move a little bit as it's eroded away. And this bank will get more and more eroded, and so we end up with more and more wiggly rivers as time goes on. And here you can see an extreme example out west somewhere. I don't know if that's Grand Canyon or not. I don't think so. So, refocusing on today's purpose, we wanted to understand how soils and rocks are moved to make landforms. We've done that now. We've seen how peninsulas are made, alluvial fans, sand dunes, islands, and river bends. All of those are made by erosion. Some of those are great. Having a new delta there, hey, you could build a house on one of those deltas maybe someday. But in other cases, it's bad. If you lived in a house right here, the erosion of this riverbank would be really bad and might break your house and carry it away. And so what do you do in order to prevent erosion from making these features?
You just stay in your house that carries down the river.
Erosion is bad because it takes away useful soil. Farmers do not want their fields to be eroded. You have the nice fertile soil on top. That's what you make your money with. If it disappears, you can't grow as much crops and you don't get as much money. Erosion is also bad because it carries materials into lakes and rivers. If you have a town next to a lake like we have here, and everybody uses a lot of yard fertilizer, that's bad because the rain will carry it into the lake and kill the fish. And so now you don't have that fun hobby to do. You don't have the tourists coming into town buying your gasoline, buying your fast food restaurant stuff, and so your economy goes down because too much fertilizer in the system. Erosion is also bad because it wrecks your neighbor's yard. When I built my house, I had to go to a surveyor, have them make a topographic map. And as we planned out where the house and the garage were going to be, where we're going to make some berms and things, we had to make sure that that wasn't going to cause water to run off from my land onto the neighbor's property and cause problems there, whether the water be running into their basement or erosion from my yard ending up in their yard. So we had to plan things out. To stop erosion, then, people devise ways to slow down the flow of water or slow down the air. Remember, when things are going slower, they can carry less material. So the best way is to have plants such as grass growing. Not only do the plants slow the flow of water, but their roots will hold the dirt in place. Farmers will plant tree lines to slow down the flow of air, to slow down the wind. So here we have a picture of the wind coming in from this side, and it hits the trees and it's going to slow down before it goes to the cropland, or the wind will be forced way up high, and so it doesn't get down to the crops. Farmers will use contour plowing. This is when they plow across a hill instead of up and down. That ends up then with curvy rows to go around with the curvy hills. Each row from the plow acts like a little dam, capturing or slowing the water from moving downhill. In mountainous areas, terrace farming has been used. I have some pictures back here of terrace farming. This is done more where you have crops done by hand. So these little stair steps were cut into the hill. They're about 20-30 feet across, so you really can't get tractors up and down to each one of these, but when you're just using a hoe and a shovel, that works out just fine. And here's some other pictures of very steep hills that you would never be able to have a tractor on, but each little row acts like its own little terrace, and so things aren't so steep on each stair step, so to speak. In building construction sites, short fences of cloth and plastic need to be put up to stop erosion. Here's a picture of that. You've seen those around, I'm sure. It's not to keep out animals. It's not to keep out people, because obviously they can just go over the top. But it's enough they dig it down into the ground a little bit, just a few inches, bury the bottom part of that black fabric. And so water that flows will get stopped, slowed down. It might go through the fabric, but going through the fabric is going to slow it down a lot and keep the dirt on one side. At roadway construction sites, you may see bales or tubes of straw. And here's a picture of that. You might see a row of bales that are lined up like this. They will stay there until the grass grows and hold down the dirt. So when water rushes down the ditch, this acts like a dam. And so any dirt that's being carried from this section gets dumped right there. As the water goes through the straw, it really slows down and the dirt will get caught. You often see green mats, green nets stretched over construction sites. Green nets, you might see green mats. I don't know which phrase I use on tests and quizzes, but you get the idea. These have grass seed embedded in them. They hold the dirt and seeds in place until the grass can grow. The mats are biodegradable, so they don't have to be removed. These black fences, you have to hire somebody to go around and get that up and throw it in the garbage. But these green nets, they just stay there forever. They break apart into tiny pieces and they disappear into the ground. They're made out of stuff that's safe for the environment. Along rivers, people will put large rocks to prevent erosion. Here's a picture of that. The water can work its way through the cracks between the rocks, but that slows it down, so it can't carry the dirt so well. Tyler?
So kind of like Michigan, where or along the bay, where they have a bunch of rocks.
That's to keep the banks from being eroded. Okay, here we have a complicated graph. Let's try to read it. What does this graph illustrate? Is it A, the amount of total soil erosion in the U.S. during 6 years? Is it B, the amount of soil erosion from farms during 6 years? Is it C, the number of years that farms have experienced erosion? Or D, the number of crops that have experienced erosion? Circle your answer now. Sierra, what do you think? B is correct. It says on cropland. So it's not the total U.S. Number 18, what is the general trend of the data? Is it general decrease, general increase, stabilizing, or more than one option? Ben, what do you think? A general decrease. We do see things going down all the time. However, it's not just A. I'm going to say D, more than one option. You could say also stabilizing, because it had a dramatic drop here from 306 to 189, but then it's not so bad. It's kind of leveling out. We'd call that stabilizing. There was an incredibly good improvement, but now it's stable at that level.
Not stable was like keeping the same.
Yep, it's keeping the same, right around 1.8.
But that's a 1.7.
That's pretty doggone close. Number 19, when did researchers start taking data for this graph? Joe, what do you think?
A.
6 years ago? Actually, something different. Chandler? C. The first graph was at 1982, so that's 3 decades ago, maybe even almost 4. All right, so on the next page we have some videos that I found to be kind of fun. We have actually landslides that are caught on video. People have their dash cams nowadays, cameras on their cars, and so we have lots of video of some amazing stuff happening along the roadside with entire hillsides of trees just sliding on down. Some sinkholes that have opened up in the middle of cities. And so what used to be an intersection is now a gaping hole that's hundreds of feet deep. Here we have a picture of a house that was on this beautiful lake, but the dam broke. The dam that was holding the lake back. And so we suddenly have the lake emptying. What used to be a lake one day, literally the next day was empty. All that water poured out. And it eroded a lot on the shoreline, and an entire house just kind of tipped over and floated down like a rubber ducky. You can check that out. I forget what this video is all about. Anyway, you might find those interesting. We have homework in Schoology, only 9 questions. You really should be able to get that done before you leave class today. Right now, would you please rip out the wrap-up sheet, put your name on it, and put it under your desk. At the last 5 minutes, I will call for those, and so you'll have them handy, and we'll go over the right answers before you turn it in.